Hi everyone. I wanted to work one more example before I leave you to your own devices, and that is this question that I posted in my lecture notes, which gives an example of a person, which I'm going to model as a solid sphere, who has mass m and radius r equals 0.4 meters. And they're sitting on a swivel chair and they catch a ball with their arm stuck out 1 meter from the sort of center of rotation right here. The ball has a mass of half a kilogram and an initial speed of 10 meters per second. I want to know after the catch, how fast is this person spinning? This is an angular momentum conservation problem. And it's much like the challenge problem where we have an angular momentum from something moving linearly initially at a distance of 1 meter away. And then you catch and this person spins around at that moment of inertia. So I'm going to call this distance L, and then my spherical person is going to have a radius R. Fun fact, the equivalent spherical radius of a person is actually about closer to 0.2 meters, which is sort of weird. Anyways, we can basically say that the final angular momentum is equal to the initial angular momentum in this case. The final angular momentum is just the moment of inertia times the angular speed. That's what we're looking for. The initial angular momentum is just the mass times how fast it's going times how far it is measured kind of perpendicular to the direction of motion through here, or basically the distance of closest approach when the ball goes by the person. So that's just given as L in the problem. The moment of inertia afterwards is the spherical person, so that's 2/5 mr squared, plus the little ball that's going to be held out there at distance L times omega final, and that is mv over L. And so I can actually just calculate omega final as mvl over 2/5 mr squared plus little m L squared. And then I just plug in all my numbers, where m is 0.5 kilograms, v is 10 meters per second, L here is 1.0 meters. Divide that all by 2/5 times the person's mass, 80 kilograms, times the radius, 0.4 meters squared, plus the little mass, which is 0.5 kilograms, times the 1 meter squared. And once we calculate that all out, you just get 0.89 radians per second. All right, hope that's useful. And toodaloo.